Storage Part 2. In this nugget, we'll be taking a look at storage. This will be Part 2, where we'll start off by discussing basic disks and what you can do with them. We'll also take a look at dynamic disks and what you can do with them. And as the name kind of almost sounds, you can do more with a dynamic disk than you can with a basic disk. But of course, these are only going to be usable by Windows operating systems. Now, one of the other things you can do is to create a mirrored volume. And this will allow you to have some redundancy and a reasonably good degree of performance as well. And then there's a couple of different kind of striped volumes you can use. Striped without any parity at all gives you great performance, or you can use striped with parity, which gives you a good balance of performance and redundancy. We'll take a look at all of these things, as well as a few other kinds of storage management features that you can use, and we'll demonstrate that as well. Guess what, folks? I'm about to celebrate 20 years of marriage to the same woman. It's been a great 20 years of marriage. I'm sure it's been better for me than it has been for her. But one thing that I find that's interesting about this wonderful woman that I'm married to is that she seems to have nearly a photographic memory for conversation. I mean, she can come home after visiting with a friend, and she can tell me just about everything they talked about. Honestly, I kind of tune her out after about 45 seconds or so. But anyway, she can still go on and on about all the stuff that they talked about. She remembers conversations that we had years ago that I don't even remember having at all. I don't know how she crams all of these conversations into her mind. I do know this. Because of that fantastic memory of hers, I don't think I've won an argument in 20 years. She's got great recall for conversation, but it must take a lot of memory to store all of that, a lot of storage in her brain to remember all of these conversations. And it's kind of like that with our disk storage as well. Now, how was that for an awkward segue? Anyway, it is kind of like that. I mean, how in the world did we wind up with so much storage? Well, we saw in the last nugget, we talked about SAN storage and a lot of other really large enterprise implementations. And now, of course, each individual hard disk is so much larger than it ever used to be that we have an abundance of storage overall. But one thing we need to understand as well when it comes to storage is how we handle them. And to start with on that, there's really two different kinds of disks that you can use. And the first type of disk that you can use would be a basic disk, and that's as opposed to a dynamic disk, which we'll also discuss. With a basic disk, you can have one of two types. One of those would be a master boot record type, and that gives you kind of a traditional partition format. You see, of course, your hard drive is going to be divided up into one or more partitions. Of those partition types, you can have up to 4 primary partition types. If you decide to create primary partitions, and of course you're going to need to do that if you install an operating system, because a bootable operating system needs to have a primary partition. You can also go with 3 primary partitions, and then you can have, in the space that the 4th primary partition would have been in, you can instead create one extended partition. And then inside of the extended partition, you can create unlimited logical drives within the amount of space that you have, and if you decide to use drive letters, within the amount of available drive letters that you have as well. Although you don't always have to assign a drive letter, as we'll see later on as well. You can also choose to create a basic GUID partition table, or GPT. This is not one we've seen quite as commonly, but it's becoming a little bit more popular for a couple of reasons. Number one, it's going to be capable of storing 128 primary partitions. Now, that seemed absurd in years past with the size of hard drives that we had. Now it's starting to become a little bit more practical because the hard drives themselves are now getting to be so gigantic. Also, a GUID partition table, it works best when you have partition sizes that are 2 terabytes or more. Okay, that's what the plus is there. I don't know if that's clear. 2 terabytes or more in size, and 64-bit. I should specify, specifically out here, Itanium processors. You don't have to do it with only Itanium processors, but certainly that is kind of what it's designed for, according to Microsoft documentation. Now, quickly here, I've just switched over to a server that I made a remote desktop connection to. This is the same server I did some WDS experiments with early in our series here. And when I turn it on, we see that it has detected one disk here that it has not initialized in the past. When you initialize a disk, that's when you specify whether it's going to be an MBR or a GUID partition table. So here we'll just choose, an MBR type, and that's, again, probably the most commonly used type. And I'll just click OK. Once I've done that, you can see I've got other drives here as well. Once I've done that, you see that it is now available for me to create any kind of a volume. Notice that it's also a basic disk. This is the default. If you want to make it a dynamic disk, and we'll discuss that again later, you can right-click on this and choose Convert to Dynamic Disk, as well as Convert to GPT Disk. And I'll go ahead and do that here as well, and you can see that once again, it has now been changed here to a GPT disk. Hey, also, I don't know if you picked this up, but when I converted it from an MBR to a GPT, did you notice that it shrunk a little bit in available size here from 24 gigs to 23.88? Why is that? Well, one of those reasons is because it also has something called a protective MBR and other data structures on it as well. But with the protective MBR allows older tools like DOS kinds of tools to be able to work with this disk. Now, normally you don't want to do that anyway because those older tools are not designed to recognize a GPT disk. But just in case you did or you had to for some reason, well, the protective MBR would allow it to interact to some degree with this type of a disk. The other thing that it'll have is in addition to the using primary partitions, it'll have primary and backup partition tables. That's for purposes of redundancy. And it'll also have a CRC32 fields, and that's going to give you improved partition data structure integrity. So overall, just the GPT type of disk could be more reliable and have a little bit of redundancy built into it. Now, we also have dynamic disks, switching back over here to my whiteboards. And with dynamic disks, one thing to keep in mind with them is they're not readable by older versions of Windows or by DOS or by any other operating system. Only modern versions of Windows, starting with Windows 2000 and later. Also, dynamic disks are not directly bootable either. So, although the word dynamic sounds really cool, and wow, why wouldn't I want all my disks to be dynamic? Doesn't that mean that they run faster or something like that? Well, no, it doesn't. It's kind of a marketing term, actually, but it does give you certain advantages, which we'll discuss. Regardless, you can't boot from a dynamic disk, so that'll still have to be a basic disk. Now, why would you need a dynamic disk? Well, that's necessary if you're going to use Windows to create these types of partitions or storage structures. One would be an extended disk. So if you have an existing disk and it does not have enough space on it, you might need to extend that. Here I'm just going to show you by way of demonstration some of these things. First of all, I'm going to go ahead and create a simple volume on this one. I'm just going to call this, data, and I'll quickly format this. And let's say that it doesn't really have enough space. Well, what I could do with this is I could extend into one of these other data structures. Now, this one's not online yet. You can't do anything with any of this stuff until it's online. So I'll go ahead and bring that online. And then the other thing I'll do is to initialize it. And we'll initialize this as let's just make this one a GPT as well, just for the fun of it, okay? All right, so now I've got a GPT disk here coming online. Then I've got this one that's still formatting. When it's done, I'm going to, we'll just assume that we don't have enough space in this. Why did I only make a 24 gigabyte hard drive? Great Scott, what was I thinking? Well, I need to borrow space out of this storage structure down here. And I can do that by extending. All right, so after that data has formatted, that partition is formatted, I need to extend it. So I'll right-click here, choose Extend to Volume, and it automatically determines where I can extend the volume to. In other words, the other two disks here are still offline, so they're not even available, but it will be able to pick up this available space on disk 2. So as I click on Next, sure enough, there's disk 2, and I can add however much space I want. If I want to be a little conservative, maybe I only want, 12,000, which would be 12 gigabytes, roughly. Then I can click Next and Finish. And then here it's also going to tell me that, what I was saying before, it needs to be a dynamic disk. Now, this is a little bit less of an issue than it's been in previous versions of Windows, because before, you had to convert it to a dynamic disk before this was even possible. Well, now, you don't have to do that, but the wizard will prompt you like this, and then you can convert it. And it shouldn't take too long. There it goes. Now it's converted this to a spanned volume that we can see here. This is just an extension. We kind of bolted on this much storage on a different disk. It's accessed by the same volume label and drive letter. And from the user perspective, even a local user, there won't be any perceptible difference. We'll still open up, my computer here, and we'll just see drive letter E. That's it. Now notice that it's 35 gigs instead of, what was it, 24 earlier. Now let me rip all of this out, and I'm going to right-click here to choose Delete the Volume. Now notice that even if I go to this place where I've extended this original data, if I right-click here and I choose to delete the volume, it rips out everything. And now I've lost all my data on the first part of this as well. So don't think that if you may change your mind about the extension later on, that you can just take that off, because that will destroy the entire volume. volume, so keep that in mind. Now, let's take a look at another thing that we can create here, and that would be a mirrored volume. And we'll just kind of check this off on our whiteboard over here. You can create a mirrored volume. In short, this is going to be where you have two disks that have exactly the same data written at pretty close to exactly the same time. And we'll talk about that in a little bit more detail a little bit later on. I'll also create it for you. We'll also see RAID 0, which is a kind of striping. This is going to have no redundancy or failover capabilities, whereas mirrored does, as well as RAID 5, which also does. But again, we'll talk more about these. But this is the type of storage that I'll need dynamic disks in order to create these types of volumes in Windows. There are also hardware solutions for things such as these bottom three especially, and they don't need to be dynamic disks. They will be managed by some kind of a disk controller. They are also operating system independent, so I could be running Linux and create these types of volumes on them. I could be running Windows. I could be running DOS. I could be running who knows what, Mac OS. So I could be running any of those kinds of operating systems, and if it's hardware controlled on these bottom three, then they don't need to be dynamic disks. But if I create and administer them within Windows, then of course they do. Alright, now I told you I'd discuss mirrored volumes a little bit more, so let's go ahead and address that again. These are also known as RAID 1 volumes, and that's what they're more commonly referred to outside of the Microsoft kingdom here, where they're called mirrored volumes. What these do is it's going to write duplicate data to two disks at the same time. There's a couple of different ways that can happen. One is simplex, and the other one is duplexing. So here's my computer right here, and then out of the back of this, let's say I'm going to use SCSI. Okay, so I'll have a SCSI cable over here to my storage disk. Now, out of the same SCSI cable, I could also attach another disk here. So these are two disks on the same chain back to my initial adapter over here. And this would be the first member of my RAID volume, mirrored volume, and this would be the second one. Anytime then that I write a file to this drive, it writes exactly the same to this drive. So if here's a file right here, that's my first file, that's my first file. Here's my second file, here's my second file. Here's my third file, here's my third file. And it writes virtually at exactly the same time. That way, if one of these drives fails, this one continues to provide service with no interruption whatsoever. You may see some kind of a warning message or something like that, or something in the event log, or if you were to use third-party types of mirroring, there may be other notifications. Some of them will send you an email or send a message to a pager or a text to your phone, that sort of thing. But Microsoft doesn't have anything quite that elaborate unless you customize event log failures, like critical errors or warnings. Regardless, if this fails, the main point of this is if this fails, I continue to provide service here. Then all I have to do is to replace the failed hard drive, and the mirrored volume will rebuild itself, and then I'll get back into business. And I'll just be up and running as normal. So I get pretty good failover with this. Another advantage of this is very little overhead when it comes to rebuilding the data. Now, what I get with this is just fair write performance. I pretty much get the same performance as if I were writing to a single disk, except that it's going to be better with duplexing. I forgot to mention duplexing. Let me go back to that. If I have duplexing, then my second disk here, instead of being on the end of that chain, I might have another controller here with a separate cable coming off of it, connecting down here. And that's how my second disk attaches. Why would I want to do that? Well, number one, because I don't have to share the throughput. Whereas if I have two disks on the same chain, I have to share the throughput. Number two, what if the controller fails? Well, if that fails, with this implementation, I'd lose both drives at once. With this implementation, I only lose one drive. The other drive, again, continues to provide performance and access to my data. So then, as far as performance is concerned, it's just fair write performance. The same performance that I would get if I just had a single disk, kind of normally attached as direct attached storage. It's not accelerated performance. It's not, hopped up kind of performance. It's just normal performance. I also do, however, get very good read performance. And let me explain to you why that would be. In fact, let me back up a couple of things here. Let's say that both of these drives were still working. And I did not lose my controller over here. Okay, so we're operating normally here. Then what could happen, though, is that I get very good read performance. Why? Because when I read, it can read from both of these drives simultaneously and deliver the data off of both these drives simultaneously. So, at least in theory, I could get almost twice the read performance that I could have off of a single disk. And then the other thing to think about is there is a disk expense, also known as overhead, with this. In this case, it's a 50% overhead. Since this is actually just duplicate data, even if this was, let's say 2 terabyte hard drive here, 2 terabyte hard drive here, since it's duplicate data, I don't get a total of 4 terabytes of storage. I only get 2 terabytes because this is duplicated. Now, where do you use mirrored volumes? They're used quite commonly in a lot of different enterprises and high-powered workstations. And very often they're also going to be used on the operating system disk because you really want to have your operating system up and running. If you lose that, you lose access to all other data and resources. Also, I've kind of illustrated this with external SCSI connections to the storage. In reality, very often you're going to have all of this storage in the same cabinet. So here's my server. I have a disk right here, and I have another disk right here. That's disk 1, that's disk 2. And they're mirrored back and forth between one another. And very often with servers, they're going to have external access to the storage, so you don't have to take the case off. There'll be a little handle up here, for example. You just pull it out, replace the bad hard drive with a new good one, and then you're back in business, and then the mirror can rebuild itself. So because that's so quick and easy to do, it is, again, kind of a favored failover method for making sure that you have good uptime with your server's operating systems. And you know what else occurs to me? I'm actually using mirroring right now, although you won't really be able to see it. Let's see, it's on this server. It's on the machine that I actually do all my recordings from. And in storage, if we take a look at disk management, it's our drive C. That's actually mirrored. Now, we can't see it as a mirror here. The reason for that is because it's hardware RAID. So it presents it to the operating system, and it looks like it's a single disk, but there's actually a BIOS utility that I use to configure my mirror. And so anyway, if a problem goes wrong with one of these drives, I just replace it, and we're still in business, really with no downtime whatsoever. Now let's talk here about a striped volume, and really it says with parity on the slide, but I should start off by talking about a striped volume without parity and show you what that looks like a little bit. Here, let's say I've got some storage here, and this could be in a computer or in an external array of some type. It doesn't really matter, but I've got 4 hard drives in this. If it's just a normal striped volume, also known as RAID 0, then there's no redundancy with this. And the way that data is written to it is the first bit of data is written here, the second one here, the third one here, and the fourth one here. Now, if one of these drives were to fail, all of this data is destroyed. You can't really recover that in any easy way. So this has no failover capability or redundancy of any kind. Now what you would have to do is if you did want to use this, you would have to have a backup solution. So you'd probably have a nightly backup. Then when you replace the failed hard drive with a new good one, you'll restore your data to these drives and rebuild your striped volume. The thing is, restoration of large quantities of data can take a significant amount of time, so you have to be able to afford a large restore window to be able to do that. Now, with that kind of thing, why would you even want to use RAID 0? The reason for this is strictly performance. Okay, strictly performance. This is extremely fast. So normally on a single disk system, you're limited to whatever the maximum throughput for I/O is to a single drive. Well, now we can take that maximum I/O and we can multiply it times 4. So theoretically, at least, you could get up to 4 times the performance. Now, there's other limiting factors, but regardless, it's substantially faster for both reading and writing the data. Now, if this is not something that you're interested in because you want to have some redundancy and some failover, you might want to switch over to a striped volume with parity, also known as RAID 5. What happens in this kind of a scenario, and let me just try to get out a little eraser here. What happens in this kind of a scenario is instead of writing data on the 4th drive, what it'll write is, it'll first a little bit of data here, second little bit of data here, third little bit of data there, and then the 4th bit of data here is actually going to be parity data, which is information about what's on these other drives. So then, if we were to lose drive 1, then this parity data could be used to reconstruct what used to be on drive 1, and it would put it back onto the new hard drive when we replace it here. This also is written in kind of a round-robin fashion. So if we assume that drive is good, our last bit of data is parity. Then the next time writes take place, this one will be parity. This will be the first bit of data, the second bit of data, third bit of data. Next time, this one will be, the first bit of data. down here, then the second bit of data, then the third bit of data, then parity. So you see how it goes. It kind of evenly distributes it across all of them. And that way, again, if any one of these drives fails, then the parity data on the remaining members of this volume will be able to reconstruct the data. Now, this also means that only one of the drives can fail. If we had a total catastrophe and we had two drives fail at once, then we could not reconstruct this data except for from a backup. Now, the thing to keep in mind with the RAID 5 volume is you cannot use that on a system or a boot volume if you've created that RAID volume with Windows, because you have to have the operating system already installed and up and alive to be able to even see it. So you don't normally put the system or boot volume on that. Now, there is an exception to that. In fact, the main workstation that I use on a day-to-day basis is a RAID 5 volume with the system and boot volumes on a RAID 5 volume. Well, how in the world did I do that? Well, I used RAID, I used hardware RAID instead of using Windows. And that, again, is where I use a controller that has RAID capabilities built into it. Okay. Now, what this is going to give you also in terms of performance, it's going to give you relatively poor write performance. And that's what documentation says. That's what Microsoft says. That's really very, very relative, however. And let me explain to you why. The reason why they say it's poor write performance is because you have to calculate the parity bit. That takes CPU power to calculate that parity bit. It's a mathematical function. Well, first of all, processors are substantially more powerful than they ever used to be. So a lot of times you can easily afford a little bit of CPU overhead to make those writes. Secondly, it's somewhat dependent upon the number of disks that you have. Notice that you have to have at least three or more disks. Okay, so if I have, let me just put in as many as I can here. I don't know how many that is so far, but 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have 9 disks here, then I'm still getting the aggregate throughput of 9 disks. Okay, so just the I/O throughput is substantial, and I'm getting only probably a small hit on my CPU performance. So even though, for the official answer, you're going to say that it's going to give you poor write performance, but in reality, it could still give you extremely good write performance, especially if you're using hardware RAID. All right. This also requires 1 disk for overhead, so that so if I have, let's say we have let's go back to our 4-disk scenario here. If each one of these is 2 terabytes, then that would be a total of what? 8 terabytes, right? But I have to subtract, because that would be times 4, that's 8 terabytes. But I have to subtract the size of one of the members, so that would be minus 4 terabytes. Is that right? People, I must be off my medication. One of the drives is 2 terabytes, right? So I would have one drive of 2 terabytes, and then that would give us a total of 6 terabytes total. And I really actually prefer RAID 5 for a lot of things because the disk cost is only 1 drive. Most of my RAID 5 volumes use 4 disks, so it's fairly affordable. So 1 disk for overhead, plus with this current CPU processors, got plenty of power there most of the time, and I get lots of throughput, so I kind of prefer this in a lot of cases. All right, now let's back up here and take a look at how we can actually make some of this stuff work. Here I've got a simple volume. It's only 10 megabytes because they're faster to work with and faster to format, only for demonstration purposes here. But if I right-click on this and choose to explore it, you can see that I've created a little bit of data here. This is mission-critical data that I don't ever want to lose. And of course, people, don't write me letters and stuff. I'm just being facetious here, just for humor. Anyway, so I've got a critical document there that I don't ever want to lose. I want to make sure that I always keep it. Well, what if something happens to this drive? Great Scott, then what am I going to do? Well, what I might need to do is to mirror this. And notice the label. So I right-click on it, choose Add Mirror, and I specify the disk that I want the mirror to be on, and I'll choose Add Mirror. Then it will convert this to a dynamic disk from a basic disk. And then we'll see that it's created another 10 megabyte partition down here, which will synchronize up, and then in just moments it will now be an exact duplicate of that data. They both have the same drive letter, and in fact in Windows Explorer there'll be no way to differentiate between one drive and the next. Now, what I could do with this as well is I could right-click here, and I could choose Remove Mirror. What that'll do is it'll remove the mirror from this drive right here. This data will be left intact. I can also break the mirrored volume, and let's just do that. We'll break it. And what that'll do is it'll leave the data on both, but it will no longer do simultaneous reads and writes. They are now treated completely independently as disks, and notice that they now have different drive letters as well. All right, let's also take a look here after I've deleted the partitions there, at how we can create a mirror from scratch. I could right-click here, choose New Mirrored Volume, click Next. Then I would choose, there's the first disk, which is already automatically selected. Then I could choose the second one. Again, I can make this, 10 megabytes or however big I want it to be. And then just next, finish your way through this. I'll perform a quick format, and then it will again convert both of these to dynamic disks. So that's just another way of doing that. Now the next thing I'm going to do while I'm waiting for this to complete is I'm going to then delete those that mirror, and then I'm going to show you how to create a RAID 0 and then a RAID 5 volume. All right, so now I have a couple of disks here. These will convert to basic disks very shortly. There they go, basic disks. Now what I want to do here is to create a new striped volume. So I'll right-click, choose Next, and then I'll just choose the members that I want to be a member of this stripe. Now, since it doesn't involve redundancy, a striped volume can be 2 or more disks. So I'm just going to stick with 2 for the time being, just to make it simple. I'll also make these really small again, just to make them format faster. And then as we click on Next, we'll just call this, striped, okay, without any parity of any kind. And then again, it's going to be a dynamic disk. Once this is done, we'll then see that we'll have a striped volume here. Any reads or writes that take place will not allow redundancy, but it will give me a performance increase. And now you can see that we do have that striped volume. Okay, and then having deleted those again, now I'm going to create a new RAID 5 volume, and we'll click on Next here. And then with this one, you have to have at least 3 disks. In fact, it won't give me a Next until I have at least 3 disks in here. So I'll just add a couple more into this. And again, I'll make them really small so that they format fast for our current purposes. And then Next, and then we'll call this striped with, well, I'll just call it parity. Striped parity. Okay, something like that. And then Next and Finish, and then again converting them to dynamic. Then we'll see that we'll now have these 3 disks that will be a stripe set with parity, also known as RAID 5. Alright, now what I've done here is I shut this machine down, and then I removed one of the hard drives, so that now we see that it has failed redundancy. I haven't actually written any data to it anyway, but this would allow me to continue to write data. It's just that I wouldn't have any redundancy in it. So you can see here, I'm still able to save data to that particular drive. But without parity data, I'm in a bit of a problematic situation. Here's the missing disk that it has detected is no longer there. If this is actually, a problem, then what I can do with this is to right-click here, choose Repair Volume, and if there's other storage that's available, or maybe this was a new hard drive that I put in to replace a failed one, for example, I could click that disk, and then as I click on through, you'll see that it will now build that additional partition here on this dynamic disk 3, and now it is resynchronized, and now we're back in business. Some other types of storage you might want to work with include a mount point, which is where I add additional storage, but I don't add an additional drive letter, and that way I also don't have to add additional mappings potentially for my users. So the way that it might work here is I've got a share already called Nugget to files. And if I double click on this, I see that there's some office supplies in here. We got a data document there. But what I've also got is an empty folder. I just called it mounted so that we could identify that this is going to be a mounted volume. What Windows will do with this is it will map drive space to this empty folder. That way when users access the original share over here at Nugget 2 Files, they'll see this folder inside of it. When they double click on it, it will look as if it's opening on the same drive, but in reality, it's opening it up on separate physical storage space, and we'll configure it this way. I'll right click and just choose, for my purposes, a simple volume, and I'll again make this really small and easy to work with. But now instead of giving it a drive letter, we'll mount it to an empty NTFS folder, and I'm going to give this to mounted right here. Then I'll just click OK, and then we'll click on Next, and then we'll again do a quick format, and I'll just call this, mounted, or for lack of a better, more creative idea. And then next and finish. And that's pretty much it. It will now identify itself in disk management as this volume, but notice that there's no drive letter associated with it. If I right-click on this, notice that I cannot explore it. That's because it does not have a drive letter. However, now when I go into my, let me just start at the root of C. Now when I double-click on Nugget 2 files, now there's a mounted item there. The folder icon is different. But now when I double-click on this, I can right-click here, choose new, data of some type, and make any changes that I want to, and so forth. So it's now a fully usable area of storage that is really mapped to an empty folder, and the users will be able to directly access it without additional share permissions or anything like that, because it will inherit its share and NTFS permissions from the parent. Although, of course, you can still modify that for your own purposes. Let's also address a couple of other types of data storage. That would be extending a volume, which we've already shown you here. And then you can also shrink a volume, and then you can expand a volume. It could be that a particular volume really doesn't need all the storage space that it has. For example, over here, maybe I've got, a 24 gigabyte partition here, and gee, this is really more space than I need. I only need a few megabytes. So I could right-click here to choose Shrink Volume. Then I could just enter in the amount of space I want to shrink it by. I'll just make it quick and easy. I'll just make it 10 megabytes. And then I'll shrink it. Now, this used to be only available by using the disk part command or third-party utilities. Now we can easily do this in the interface. Now, let's also take the converse. Maybe this was too small of a partition, and I need some more additional space. I could right-click here, and I could choose to extend the volume, and click on Next. And then I could select that drive, this item right here, and I can use the 10 megabytes that are at the end of it already right now, and if I want even more, I can select additional disks and add even more space. So that's also an available option. I'll just make this one 20 megabytes. So we'll add a few different megabytes this way, and then click on Finish. Again, this drive here will have to be converted to dynamic as well as this one. But otherwise, I now have kind of just a quick and dirty way to get extra storage space out of something without having to format a drive or add a new hard drive and then restore from backup or any of the other more messy methods. Then let's take a look at a couple of other types of storage here. One of those would be extending a volume, which I've kind of already shown you to some degree, but I want to show it to you again, sometimes also referred to expanding. But in the interface, it says extending, and then here I'll also show you about shrinking a volume. Now, here I have an existing volume that I want to shrink. Maybe I don't need all that space, or I want to carve out an additional space here at the end for a different partition or whatever. So I'll right-click here to choose Shrink Volume. Now, this used to be only available if you were using DiskPart, the command line tool. Well, now I can shrink it, however much. I just chose 10 megabytes, which you can see here, rounded to 11. Now I can choose to extend that volume, and then what I can do with this is using the up and down arrows, I can go up and down to select the available storage space. Now, this is a little bit of a mystery to me. I don't know if you noticed when I first got into this, it said 11 megabytes were here, but it would not let me click on Finish. If I use the spin dial to adjust that, it allows me to go only up to 10, but now I can click on Next. Okay, so for some reason, you have to go slightly beneath what the available storage space is. And now we see that it is extended to the end here of the available storage space, and it did that without making this a basic disk. One thing I could have also done, just like I showed you earlier, was I could extend the volume, and I could also pick data out from another drive. If I do something like this, then as I next finish my way through this, this would have to be converted, and actually both these disks would have to be converted to dynamic disks. And then finally, we can use the DiskPart command. This is a command line version of the tools that we've already been using here so far. It can do virtually everything that on the command line that you can also do using the UI. So for example, here I was able to shrink and expand this using the UI. If I go to a command prompt here, I can run DiskPart. And by the way, we can run the whole thing on a single command line, but I'm just going to go to the DiskPart command prompt to show you how to do it from there. What you'll need to do with this is to select a volume that you want to shrink. Let me show you some other things you can do first, though. One thing you want to do is get an overall context of what's available. So I can do a list disk, for example, and that shows me all of the available disks. I can also do things such as list volumes, and it'll show me all the available volumes. Notice that I didn't have to type out the whole word volume here. As long as you type in enough unique characters, then it will be able to fill in the rest for you, and it identifies that I'm looking for volumes. Now what I want to do is maybe I want to shrink something. If I want some help on how to use the command, I can do that. What I want to do is to type in shrink and then desired, specify the size of the desired amount that I want to shrink it by. But if you don't know the whole syntax, you can do help, shrink, or whatever else the command is. And I'll just say that I want to shrink, actually select, did I select the volume yet? Volume 2, I think I did. Anyway, now I want to shrink desired equals, let's say 100 megabytes. Okay. Now I've shrunk it by 100 megabytes, and I can confirm that back here in the interface. Okay. And again, because of rounding, it doesn't show exactly 100 megabytes. The next thing I might want to do is just to extend. Okay, so I just type extend, and if you don't specify the number of megabytes, it'll use all the available megabytes, and you can see that now I've extended all the way out to the end. So, just in short, that's just a small example of how you can use diskpart, and that's something else that you don't need to memorize all of the syntax, but you do need to know that you can use this tool to manage your disks in Windows Server 2008. In this nugget, we took a look at storage. This was part 2, where we started off by taking a look at basic disks. And this is the kind of conventional disk that we've always been accustomed to using in the past, way back since, like the days of DOS. We also took a look at dynamic disks, which started new with Windows 2000. And this gives us the ability to do things such as create mirrored volumes or a striped set with parity. It also allows us to create a striped set without parity, but with parity, of course, is going to give us an additional level of redundancy. And these all, by the way, perform with pretty good performance as well. We also took a look at a few of the other types of disks that you can work with, such as the ability to shrink or extend disks. And also we took a look at the diskpart tool. Well, I hope this has been informative for you, and I'd like to thank you for viewing.